All right, so we're in section 5.3. So what we're going to be doing in this section is this time for this section we are allowed to work across the equal sign. So we're not verifying identities anymore. We have an equation like 3x plus 5 equals 7, something like that. And we want to solve the equation, except our equations have trig functions in them. So we're going to use all the techniques that we use to solve equations in algebra. So we're going to combine like terms, we're going to factor, we're going to subtract things from both sides of the equation, all that kind of thing, just like we did in algebra. But we're also going to apply what we know about trigonometry because our equations are going to involve trig functions. And our solutions, rather than x equals, we're going to have an angle, theta equals. So often when we're solving trig equations, we end up going back to the unit circle to find our answers. So what I want to do is give us some general guidelines and then just go through a few examples of solving these equations. So there's not much new to talk about other than just working through some of these problems. So in general, we want to isolate the trig function. And I'm going to put a parentheses functions on one side of the equation. So just like in algebra, we wanted to get x by itself on one side of the equal sign, we want to get our trig function by itself on one side of the equal sign. And then we want to solve for all the angles that make the equation true. And we have to include coterminal angles. But including the coterminal angles is easy. So we'll talk about that when we actually do it. So this is our general idea. So just like solving equations in algebra, there's not necessarily one technique that you use to solve every kind of equation. You solve linear equations differently than you solve quadratic equations. So we're going to go through those processes to solve these various kinds of equations. So I just want to work through some examples. So let's take a look at, so all of these examples we are going to solve. Um, 1 minus 2 cosine x equals 0. So this would be, for the quiz tomorrow, this would be the kind of the level of difficulty that the problem solving an equation would be. All right, so let's isolate our trig function. So I'm going to add 2 cosine x to both sides. So I get 2 cosine x equals 1. Divide by 2 and I get cosine x equals 1/2. All right? Yes? I added 2 cosine x to both sides of the equation, and then I divided by 2.
Oh.
Yes?
That's not it. Is that all you do?
Almost. So now we say, where on the unit circle is cosine equal to 1/2? We say x equals 5/3. And to get our coterminal angles for sine and cosine, if we go around the circle one more time, we get back to the same solution. Our period for sine and cosine is 2 pi. So we add plus 2n pi. N can be just any integer, 0, 1, 2, 3. So any multiple of 2 pi takes us back around to the same place.
So is that for all of them? So any of these you add plus 2n?
We'll talk about tangent and cotangent in just a second. Yes? No, nothing that complicated. Nothing that complicated. But now there's one more answer, isn't there? What's that? It could be plus or minus, but and we take care of that by saying and could be positive or negative. And could be 0, 1, 2, 3, negative 1, negative 2, negative 3 also. So what's our other possibility that gives us cosine x? How many 5/3? 5 5/3. Alright, so we have this first quadrant angle and we have this fourth quadrant angle. That gives us a cosine of 1/2. And there's our answer. X equals pi over 3 plus 2 n pi, or x equals 5 pi over 3. All right, questions there? All right, let's look at another one. All right, we're still solving. Well, you guys are worked up today. Did you have extra caffeine at lunch or something? Tangent squared x minus 3 equals 0. All right, so let's focus, guys. What are we going to do here? Tangent squared x, we add 3 to both sides, equals 3. Take the square root. Now we need to be careful here. Tangent x equals, when we take a square root, plus or minus square root 3. Be careful with those square roots. All right, so then we say, where on the unit circle is tangent x equal to positive or negative square root of 3? 5/3. And because the period of tangent is pi, we don't add multiples of 2 pi, we add plus n pi. Period of tangent is pi. Same thing with cotangent, we add n pi. All right, what's another possibility? We have a plus and a minus. So aren't there two angles that give us a positive square root of 3 for a tangent? So in the first quadrant, where else is tangent positive? In the first quadrant and the third quadrant. So what's our third quadrant angle that gives us 4 pi over 3? There we go. All right. And we're saying n pi for tangent because the period of tangent is pi. And then don't we have a couple more? To give us our negative square root of 3 answers? 2 pi over 3 plus n pi, and x equals, what's our other one? 5 pi over 3. So these two give us our positive square root of 3 answers, and these two give us our negative square root of 3 answers. Now one thing for these kinds of problems that you'll see in the book is they would give this answer, and they would give this answer. Let's take a look at why. What we did here is not incorrect. This is fine. But sometimes you'll see just the two answers. If we're here at pi over 3, and we add pi, where does that take us?
Right there.
What is this angle? This, so we add pi. This takes us to 4 pi over 3. Adding pi, 1 pi to pi over 3. So we get this angle from this one. And if we're over here at 2 pi over 3, and we add pi, we end up down here at 5 pi over 3. So if we add pi to this angle, we get this angle. So sometimes you'll see the answers just written, you'll have two answers rather than all four. I would accept either. This is not incorrect. This is not incorrect. This is like saying when you solved an equation in algebra and you got x minus 2 squared equals 0. So you say that's x minus 2 times x minus 2 equals 0, right? That's like saying x equals 2, x equals 2. It's the same roots, it just happens twice. So this, not incorrect, what we just wrote here. Writing all four of these is not incorrect, but writing this one and this one is not incorrect either. So I just want you to realize when you see those answers, that's why those answers might not look like your answers. This is fine.
If we only get those two on the class, we get one.
Yes. But if you told me it was just these two, then you wouldn't get full credit because then you miss the negative square root.
Yeah.
Okay. So that's why you see the answers written like that. All right. Questions on that example?
Well, there's probably
No. Like that first one. More like that very first one. All right. Let's look at another one. Secant x cosecant x equals cosecant x. All right. So what do we want to do here? All right, let's be careful. So the suggestion was to divide by cosecant x. If we're dividing by cosecant x, what are we assuming? No? We're dividing by this function. So we're dividing by something. What do we need to be true when we divide by something? It can't be 0. So if we divide by cosecant x, we're assuming that it's not 0. Can cosecant x be 0? Maybe. But so what else could we do?
Turn it into line.
Rather than dividing, what do we do? How about subtract?
Oh, yeah. Because then you just factor out.
All right, so now what do we do, Ali? What did you say?
Factor out.
Factor out cosecant x. All right, so when we have an equation like this, what does this tell us? Cosecant x equals 0? Or secant x minus 1 equals 0. Now let's look at each possibility. So cosecant x is 1 over sine x equals 0. Can 1 over sine x equal 0? What would have to be true? What would make this fraction 0? The numerator or the denominator being 0? Numerator. Is the numerator 0? No. So this is no solution. For this side. Yes?
Wait, I'm confused. If it's secant x minus 1, wouldn't that mean that secant x is equal to 1?
Right, so we'll take care of that one next. So secant x, that's the other possibility, is secant x. So this piece gives us no solution.
Oh.
Secant x equals 1, that's our other possibility. And where, let's say what secant x is 1 over cosine x. And when is this equal to 1? When cosine x equals 1. Where on the unit circle is cosine x equal to 1?
0 and a 5.
Is it just positive 1? Is it equal to 1 at pi? No, it's negative 1 at pi. So it's just going to be 0 plus 2n pi. And you wouldn't have to write that 0. So our answer is just 0 plus 2n pi or 2n pi. So in this one, it turned out we would have been okay if we divided by cosecant x. But in general, you want to subtract rather than divide. So it's kind of like when you had an equation like x squared minus 1 equals x. You don't divide by x, you subtract x from both sides. Same kind of idea. All right, questions on that example? Okay, let's look at another type of problem. Two cosine squared x plus cosine x minus 1 equals 0. All right, how are we going to approach this one? Factor, yes. This is exactly like, and we simplified these kinds of problems before. We simplified them. This is exactly like 2x squared plus x minus 1 equals 0. Solve that, we factor it, yes? So we're going to factor this as 2 cosine x and a cosine x to get the 2 cosine squared. And I need a 1 and a 1 here to get a negative 1, right? So what are we going to do? Plus 1, minus 1, is that right?
Yeah.
No? This gives me a negative 2 cosine x plus 1, so that would give me a negative cosine x. So I need to do it the other way around. All right, and this tells us that 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. And for this possibility, I get cosine x equals 1/2, or cosine x equals negative 1. Now we say, where on the unit circle didn't we just solve this problem? Where cosine x equals 1/2? X equals pi over 3 plus 2n pi, and x equals 5 pi over 3 plus 2n pi. Now we say, where is cosine x equal negative 1? Pi plus 2n pi. And you could also write this when we could factor this pi out. You might also see it written as 2n plus 1 pi. Yes? All right, so the question was, could we find the inverse cosine of 1/2? One, for the quiz and the test, it'll be no calculator. And two, when you put the inverse cosine in your calculator, how many answers did it give you? 1. But we know there are 2 answers. So you would have to be able to figure out, okay, from that, how do I get the other answer? Remember that question on the test where it said, solve the equation cosine theta equals something or other? There should have been 2 answers. All right. Questions on that example? Now, let me expand on Sam's question really quickly. If you had an equation that didn't come out nicely, where you ended up with something that you recognize from the unit circle, so it said cosine x equals like 0.578, then you would have to use the inverse cosine to find one of the angles, and then you would have to know how to get the other angle from that. Do we know how to get the other angle? So here's pi thirds. The other angle is down here. 2 pi minus theta would give us the other angle. And if we're over here, the other angle would be down here. So that would be pi plus theta. So you'd have to know how the unit circle works there. All right, are we good with that example? Let's look at another one. We just have a couple more now. All right. So we want to solve this. What's our first issue here? We have a cosine and a sine. They're mixed together. We can't factor this the way it sits. And because we have a 3 here, we can't factor like we did the very first problem with the cosecant and the secant. So what do we have to do?
We switch the cosine square x to
Switch the cosine squared x. We have an identity, right? We know how to work with identities. Cosine squared x is
1
minus
sine squared.
sine squared x. So we know how to work with these identities, so sometimes we have to do these identities when we solve these equations. Now I'm going to distribute here, and I get 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. Combine like terms, so I get minus 2 sine squared x plus 3 sine x minus 1 equals 0. I don't like that negative 2 sine squared x. How can I get rid of that negative? How can I change that? Multiply or divide by negative 1. Because this side's 0, so it's not going to change anything over here. So multiply everything by negative 1, and I get 2. I wouldn't have to do this, but I think it makes it a little nicer. So I'm just changing the signs on everything. And now what can we do here? Now we can factor. So I get 2 sine x and a sine x. And I know I need a 1 and a 1. And what do I have to have? A negative and a negative. Did we do that right? Think so? Negative 2 sine x minus 3 sine x. So this tells me that sine x equals 1/2. Or sine x equals 1. So for this one, now we say on the unit circle, where is our sine equal to 1/2? Pi over 6 plus 2n pi, and one other. Seven pi over 6 is in the is it 7 pi over 6? That's in the third quadrant. 11 pi over 6 is in the Macy says this one. So what is that one? The other one up there in the second quadrant. 5 pi over 6. And then for this possibility, I get x equals, where is sine theta equal to 1? Pi over 2 plus 2n pi. And there are my answers. Kind of nice. Kind of nice. All right, questions on that example? Okay, one last example that's just slightly different. All right. Sometimes you will have equations that have multiple angles. So I'm just going to put a little header up here. Nothing really different until the very last step. So let's look at the example 2 sine 2t equals 2 sine 2t plus 1 equals 0. So here we have a 2t instead of an x. So we have to be careful at the very last step. So I'm going to get my trig function, isolate my trig function. So sine 2t equals negative 1/2. And now I look on the unit circle and say, where is sine equal to negative 1/2? But when I do this, I'm saying 2t equals whatever this angle is. We're solving for this whole thing. So where is sine equal to negative 1/2? 7 pi over 6 plus 2n pi, and I'm going to leave some space. 2t, I'm solving for this whole thing. 2t equals, and what's our other one? the other one we left out last time? 11 pi over 6 plus 2n pi. I want to solve for t, not 2t. I divide everything by 2. T equals 7 pi over 12 plus n pi. And here I get t equals 11 pi over 12 plus n pi. Divide everything by 2 at the very end. So this one should be n pi. 2 n pi. Yeah. So we divided this whole thing by 2. Divided 11 pi over 6 by 2 and divided the 2n pi by 2. Because we divided it by 2. We divided the 2n pi by 2. So for multiple angles, we're solving for whatever the multiple angle is. At the end, you have to divide by whatever this multiplier is. And if our equation were 2 sine t over 2 plus 1, we would end up at the end here equals 0. At the end we would have t over 2 equals 7 pi over 6 plus 2n pi. Or t over 2 equals 11 pi over 6 plus 2n pi. So we still have a multiple angle. Our multiple is just a fraction. So in this case we would get t equals multiply by 2, 7 pi over 3 plus 4n pi. And this would be t equals 11 pi over 3 plus 4n pi. So this time I multiplied everything by 2. So that you just have to take care with that last step to take care of that multiplier on your angle. So that's the only difference when you have a multiple angle. All right, questions there? All right. So homework. I'm going to put up the homework. I'm going to write up 5 separate problems in red. I want everybody to do those 5 problems first, and then towards the last 10 minutes of class, we will put up the solution so we can have a check-in on these. All right, and then the 5 that I want you to, everybody to get ready to go. Let me find them. I'm going to put them. So do those first. Do these 5 first, and then start working on the other ones. In the last 10 minutes, we'll put solutions for these up on the board. So everybody knows.